Hi, in this session we are going to learn about the concept of links on Linux platform. We'll be learning about the hard links as well as the soft links. Before we begin with the concept of links, let us try to understand what really happens when you create a file. When you create a file, a data structure called as an inode gets allotted for a file. The inode data structure basically contains the metadata information about the file. It contains information like the access permissions. It also contains information about the owner of the file as well as the group. Then it contains information about the creation and the modification time of the file, and it also contains pointers to data blocks. If you want to know the inode number of a file, we can just use the option ls with an option I. This will give you an inode number along with the file name. But if you want to know the long listing or you want to know the inode number in the file 1, we can basically use I1 or we can use li. We've seen that every file has an inode number associated with that, and we can view that inode number with the option I along with the ls command. Right now, let us try to learn about links now. Links can be of two types: hard links as well as soft link. Soft links are similar to shortcuts on Windows. To create a soft link, we basically use the option ln with an option -s. You give the existing file name. Like for example, let us say I do have a file name called as test.txt, and then what is the shortcut name you want to provide for this? I would like to provide something like my shortcut.txt, and then you can just list the files with li, and you can observe few things out here. The first thing what you can observe is the type of the file is mentioned as L stands for link file. Then the next thing what you can observe out here is there is a change in the color of this particular shortcut file, and you can also observe that it is pointing to the actual file. Right now, this has a separate inode number when compared to your original file. The original file had an inode number 416, and then this had a number like 200. Fine. You can access the original file through the shortcut. Like I would like to print the contents of test.txt through the shortcut. I just write cat my shortcut.txt, and this has the same data as test.txt. And not only that, if I want to edit the file, I can edit the file using the original name as well as that shortcut name. I'll just try to add a line, my shortcut.txt. This is the new line added through shortcut. Fine. Now I'd like to view this test.txt. You can just observe the file is being added. Or you want to remove some files through the original file, you can just observe, you can just see, we have already seen with respect to test.txt. Now we'll just try to see this, both are printing the same values. Now let me just try to use a vEditor and try to remove some lines out there. I'll just try to go to the original file, and I'd like to remove some lines out here. Right. After that, after saving this file, you can just see this is my test.txt. The data is removed. Now I'd like to see that my shortcut.txt, you can observe that even when you watch through shortcut, it is showing me the contents of test.txt only. Now let us try to look at the size of the shortcut file. Now here you can just observe it is mentioning it as 8. Why is this 8? This 8 is the number of characters in test.txt. Now let us say I create a shortcut for this Indian states.txt, then this particular value will be equivalent to the number of characters as in Indian state.txt. Let me try to create this ln-s. So I'll just try to say Indian states. I'll just write states.txt. Right, ls-li. You can just observe this out here, states.txt. It is 16 here because the number of characters in this is 16. Since this shortcut file only refers to the original file, the shortcut is meaningful as long as the original file is existing. But if the original file is deleted, the shortcut file is meaningless. Let us try to delete all of the original files. I'd like to remove this test.txt, right? So you can just observe here that the color of this is changed out here, indicating that this is okay, there is a broken link out here, meaning the file to which this refers to, that file is not existing. If I try to print the contents of this with the help of the cat command, right, now since the original file is not there, you can just see it says that no such file or directory. In fact, we do have my shortcut.txt, but what we don't have is test.txt. There are a lot of symbolic links or soft link files in a directory called as /etc and alternatives, right? So one of them I'll try to look out here as like x-www -browser. Now this refers to /usr /bin and Firefox. Now let me just show you out here that I don't have my Firefox open, but I like to open this Firefox. There are two ways through which we can open. I can either specify this particular program and launch the Firefox, or I can also use the shortcut to launch the same thing. Now let me try to use the original one. I'll just try to write /usr /bin and /Firefox. You can just observe that it's going to launch this Firefox program, right? Okay, let me just close this, right? Now I'd like to open the same Firefox through the symbolic link. So I'll just try to write /etc alternatives x-www -browser, and this will also open the Firefox. So you can just observe we could open this either through the actual file name which is present in usr /bin Firefox, and we could also do it through the symbolic links. We can also create soft links for directories. Let us try to create a soft link for this particular directory called a Sikandar, and I'd like to put it on the desktop. So first let me just come down here, okay, to the parent directory where Sikandar is a directory present in that. Now to create this soft link, I'll just write ln-s. Let us give the full path for this. That is a home. This stands for home directory, and inside this you can just see we do have Sikandar. So this is the actual folder, and where do I want to put it? In the home directory, and I'd like to put it on the desktop, right? I'd like to pass on this, okay, sec short, right? Okay, now you can just observe that here a shortcut was created, and let me just try to see what is the contents present in this Sikandar. You can just see pwd, we are in home Varsity Sikandar, okay, and then these are the files what we had here, and then here also when you try to open it, you can just observe it's going to refer to the same thing out here. Now let's learn about hardlink. Hardlink is just like giving alternate name to an existing file, and it does not create a separate inode like how it created in a soft link, but instead it increases the reference count. Now let us observe this reference count using the help of the ls-li command. You can just observe this third column after the permissions. This is basically called as the reference count, like how many names have been used to refer to this particular file. As of now, you can just observe all the files in this particular directory are referred by a single names. Now I'd like to create a hard link to an existing file. In order to create a hard link count, we use the command ln without the option -s, and then we'll specify the existing file. Let's say I would like to create a hard link for file1.txt. I'll just write ln space file1.txt, and whatever is the link name you want to provide, right? I'll just write hlink.txt, and now let us try to observe this out here. Please do observe the reference count is increased from 1 to 2 for this as well as for hlink.txt. That's one thing what you can observe. The next thing out here is we can just observe that the inode number for this is same. So a single inode referred by multiple files. Now it's the same, okay, like you can access the same file using file1.txt or hlink.txt. Let us try to look at the contents out here, file1.txt out here, and then let us also try to write hlink.txt. Now let us try to add some data out here. Now let us say that I'd like to add up some data to this file1.txt. I'd like to say that Bangalore, Control D, and you can just observe this file1.txt has the updated data. The same way, even this hlink.txt also has the updated data out here, right? So you can access the same file using any of the names. We can have any number of hard links for this. Now, if you remove a file, will it be removed from the disk immediately? The answer is no. If the hard link count is more than 1, it will only reduce the hard link count, right? As you can just observe, file1.txt and hlink.txt has an hard link count of 2. I can remove any one of this. I can either write file1.txt or hlink.txt. Let me just try to write file1.txt, and I'd like to print this. You can just observe hlink.txt out here, reference count has been reduced from 2 to 1. Right now, in case if the reference count is 1 and if you try to remove the file, that file will be permanently deleted. You can just observe this rm hlink.txt. Now this is going to delete the file. Right. Let us try to create multiple links for file2.txt, ln file2.txt, then hlink1.txt, ln file2.txt, hlink3.txt, right, this way. So you can just observe we create two short links, we create two hard links, and you can just observe that it is 3 out here, it is 3 out here, we can 3 out here, fine, okay. But there are some restrictions with respect to hard link count. We cannot create a hard link to a directory. Like for example, I'd like to come back here, I'd like to create a hard link count for the directory, right. I'd like to create hard link count for this. I'll try to say folder shortcut, and you can just see hard link not allowed for directories. Fine, thank you.